Good morning. Good morning. Okay, so today there's a problem with live stream. There's a very long delay for some reason. I tried this morning, but it's like have a 15 seconds delay, which I guess is fine, but we will see, okay? So everything is posted in Google Classroom, and today we're gonna start 8.1. Let me pull it up. Mm, okay. All right, can you see my screen? Hi, Nancy. Good morning. All right, let me pull this up. Hi, Katie. Hi, Rachel. Hey. All right, so we're gonna go ahead start for 8.1, and if you have questions, just go ahead ask me, and I have another screen pull up over there on my another computer, so I can answer your question over there. Okay? Hi, Mia. Hi, Victoria. You changed your name. Thank you. And Ola. Hi, Jackie. Hi, Jackie's daughter. Hi, Darren. All right, we're gonna go ahead and get started. You can see my screen, right? Let me see. Okay, awesome. You know what? Actually, this session do not have any delay, which is awesome. Happy St. Patrick's Day. I should wear green, darn it. Okay, all right. So just let's quick review about what we talked about in last unit. In last unit, we are finding sample distribution, and we are finding the sample distribution for mean and standard deviation. And in this session, we're gonna tell you how we're gonna apply what we learned. So 8.1, we're gonna talk about confidence intervals. Confidence intervals is basically saying, okay, so if you use your statistic to estimate your parameter. So for example, if you say, okay, so we're gonna say, okay, what's a good example for that? Okay, my head go totally blank. So let me pull the camera up so you can see me. 1 second. All right, hi. So I'll give you an example. So for example, we want to see, um, who can give me an example? Uh, oh, thank you, Fred. Nancy, is that better? Yes. Okay. I don't know. Did you say yes? Okay, awesome. So, for example, let's what a good example will be. All right. So, for example, like, do you remember there's a question we did before and saying in a manufacturing, and there is a bunch of scales, and like how many of them are like accurate and how many of them are not accurate. So our population will be for all the manufactured scales and see the proportion of they are accurate or not. And then our statistic is we take like 10 random scales and see if they are accurate. So we are basically want to use these 10 scales to estimate if the whole factory, the parameter, if they are accurate or not. Okay, so um, confidence interval is saying if my parameter is saying like 80% of them are accurate, then what is the range that we can capture most of the we can capture most of the data, most of the sample, most of the statistic in our data. Okay, all right, am I confusing you right now? Oh, okay, let me try this. Ulisa, does that solve the problem? I think I don't know. Hmm, interesting. Okay, I think I just solved the problem. It's just need to be Viking proved. Try it again. All right. So let me pull the screen up. Okay, here we go. Hmm. All right, give me a second. Let me see if I can use Fred's way to make it no delay. Okay. Fred said settings in bottom left, settings, and then advanced, stream delayed, 0 second. Oh, all right, hold on. Oh, hold on. Okay, guys, uh, if you drag your I don't know what's that called, like the bar to all the way to the end, they should know have the no delay now. All right, so if you just join us, please go to the Google Classroom, and we are talking about 8.1 now. Okay, today we are talking about the confidence interval. I just get started, so you didn't miss anything. Okay, okay, Balto is live. He's being crazy downstairs. All right, so first definition we're going to talk about is point estimator. A point estimator is a statistic that provides an estimate of population parameter. So for example, if like the scale problem, if we want to find the proportion of if how much of the scales are accurate, then we use a point estimator p as the sample proportion. Okay, so all your sample mean, sample standard deviation, sample proportion, we call all of those a point estimator. Okay, basically it's just a statistic we talk about in chapter 7. The value of the statistic from a sample is called a point estimate. For example, if your point estimator, which is your sample proportion, is 50%, then the value of then your point estimate is 50%. Okay, I know it might be a little confusing. I want to show you an example. If you can pull up to the next screen, okay, your screen is exactly the same as mine right now. So let's look at problem number 1. Uh, what what do you mean is restricted? So you cannot hear me or something? All right, so question number 1, they said quality control inspectors want to estimate the mean lifetime meal of the AA batteries produced each hour at the factory. They select a random sample of 50 batteries during each hour of production and then drain them under conditions that mimic normal use. Here are lifetimes in hours of batteries from one each sample. Let me see if I can show on it. All right. Okay, anybody know how I draw on this? All right, so let's focus on what we're doing here, okay? So what does this 50 represent? This is a sample size, right? I'm kind of talking to myself. That's a little weird. Okay, so 50 is our sample size. And what is our population? You need to think about what is your population, what is your statistic, and we just learned that the point estimator is your statistic. So what is that? Okay, you can comment on here. I can see you. So you want to estimate the mean life of mu. This is your, over here, this is your population. Okay, you can now see it. So the lifetime mu, this is your population. Okay, and then the 50 batteries is your sample size. Okay, and then the point estimator you want to use is within these 50 batteries, you want to see what is the sample mean. Okay, how to calculate the sample mean is you're gonna add all of them together and divide by 50. So that is your point estimator, is your sample mean. Uh, anybody can help me how I write on the PowerPoint? Okay, I need to figure that out. I need to write. Oh my god. So tips. Alright. How I'm searching it. Do I write on Google Slide? Okay, this is not giving me anything. All right, so okay, so the point estimator for this one is it's the sample mean, which is you are gonna add them together, divide by 50. Okay, and then the point estimate, the actual estimate itself is the number you get from this process. So your answer will be the sample mean x bar is your point estimator. The point estimate is you're gonna add them together, divide by 50. Okay, we will not actually do it because as Ashley said, well, there's no calculator. Give it to you. Okay. Okay, you have a calculator. Congratulations. Okay, so this is A, and let's look at B. B said, what proportion P of U.S. adults would classify themselves as a vegan or vegetarian? Pew Research Center report survived 1,473 randomly selected US adults. Of course, 124 said they were vegan or vegetarian. So for this one, what is your statistic? Andrew, there's no faster way to calculate that. Like another way I can think about is you can insert all of them in your table and you do one variables calculate. They can give you both the mean and standard deviation and whatever you want. But there's no faster way to like type in the data. You have to get it in first. All right, very good. So Ashley said the point estimator is a proportion. Okay, it's a proportion inside your sample are vegans. Okay, that is your point estimator, and your point estimate is 124 divided by 1473. Okay, so sample proportion P is your point estimator, and your point estimate is your sample proportion you calculate from here. Okay, everybody good? Okay, I just assume you're good. Okay, all right. So the C, the quality control inspectors in part A, okay, over here, want to investigate the variability in in battery lifetimes by estimating the population standard deviation, sigma. So, what is your point estimator here? Okay, top of the slides, click Fred, I do not have that option on mine. I don't know how to do that. You see it? I need Fred come here help me with this process. Where is that? Left. Left. There's nothing left. Go left. Like the shapes are. Left hand side. Left present mode. Left present mode. Left, not right. This is left. I gonna go edit the side. Leave present mode. Okay. Leave present mode. Left side, shape. Oh. I want to draw on it. Like a pointing thing. A line. No. Leave that jaw. Go there where it lies. Leave that jaw. All right, you know what, Fred? We're gonna talk about this later. Okay, today we're just gonna go with that. All right, I'm sorry. Let's go back to the. Uh, let's go back to number 3. The quality control inspectors in part A want to investigate the variability in battery lifetimes by estimating the population standard deviation of sigma. So this one, your point estimator will be your what? Will be your standard deviation for the sample standard deviation. Okay, and then your point estimate, you're gonna find the standard deviation for everything in the table. Okay, for everything over here. So the fastest ways to do that is what I told Andrew earlier. You're gonna insert all this data in your table, in the stats edit table in your calculator, and then afterwards you're gonna hit one variable stats and pull up your stats table, and over there they have your mean and standard deviation you need. Okay, so over here the sample standard deviation is your point estimator, and the point estimator is this is from your calculator. Okay, all right. Okay, so if you don't have a calculator, you can use Excel or like a online software to do that. They can all give you this answer. Okay, all right. So let's take attendance very quick. Use your words to tell me what is point estimate and what is the point estimator. Okay, everybody just type in your answer and I will see who is here. Okay, what is the point estimator and what is point estimate? All right, go. Yes. Well, the formula for standard deviation is the formula we used before as the square root, the value minus the mean square over n minus 1. But in here, we do not need to use any formula for that. We just get it from the calculator. Good job, Rachel. Okay. Okay, the difference between a point estimator and point estimate. The point estimator is a statistic. For example, it's you're gonna express that in English. You can say this is the sample mean, sample standard deviation, sample population. Okay, and then the sample, the point estimate is the value they estimate. For example, you can say the sample mean is my point estimator, and like maybe say 26.5, which is my sample mean, is my point estimate. Okay, so point estimator is the name of the statistic. Point estimate is the value you actually get. Okay, good job, Riley. Okay, good job, Ulisa. Okay, good job, Fred. Awesome. Okay. All right, is everybody already signed in? Okay, good job, Tucker. Yes, exactly. Let's look at Tucker's comment. Okay, the point estimate is the numerical value you actually get from your statistic. Point estimator is the name. Yes, yes, exactly, Tatiana. Point estimator is you can understand it is the name of that number you get, and the point estimate is the value. Point estimate is the numbers. Yes, Mildred. Okay, let's keep moving. Okay, awesome. And the confidence interval. All right. Okay, confidence interval gives an interval of all possible values of a parameter based on the sample data. Okay, so for example, we are saying, let's use the example over here. So the confidence interval is saying they give you a range, all the possible values for what's the battery life you can. So over here, if your confidence interval is saying like from 15 to 18, which means in this range 15 to 18, they can capture most of the battery's life time. This is confidence interval. It's an interval we use to estimate the parameter. No, it is not only for mean. It is for whatever statistic you use. Okay, it's not only for mean. So look at the cartoon, like under there. They said, taking a look at tomorrow's weather, the highest temperature will be between a 40, negative 40 to 200. Okay, so this is not how we use the confidence interval. Yes, confidence interval is a range. We want to put all the possible values inside, but this range have to be a reasonable interval, reasonable range. You cannot say, okay, just get a crazy thing and say, okay, this is never wrong, so just go with that. You cannot do that. We need to use a reasonable range and to capture as much as value we can. Okay. All right. So this is confidence interval. Confidence level give us an overall success rate of the method used to calculate the confidence interval. That is saying in C% of all possible samples, the interval compute from the sample data will capture the true parameter value. Okay, so confidence level is saying if, for example, if C is 95%, we are saying 95% of all possible samples, the interval compute from the data will capture the true parameter value. So over here, we will going to learn confidence interval, how to calculate a confidence interval. Not in 8.1, but 8.2 and 3, we're gonna really calculate the confidence interval. So far, you just need to understand confidence interval is something like according to all the different sample, people calculate from that. And the C is how much of the data the confidence interval can capture. Okay. All right. We will look at example. It will be more clear. Let me see. So confidence interval has to be no, yes, confidence interval has to be realistic, have to be from the data. You cannot just make it up. What class? there is formula for confidence interval. When we look at the data, we have to use a formula to like calculate confidence interval. So that range is what's saying how much percent of the data you get. There is formula to find confidence interval, Tatiana, but we haven't learned yet, but we will give it to you. You need to use the formula. Okay? All right. So right now we just want to show you how to interpret the confidence interval. There are different ways to interpret confidence interval and confidence level. So over here is for confidence interval. So to interpret a C% confidence interval for unknown parameter, you will say we are C%, which we use 95, okay? We are 95% confident that the interval from what to what capture the parameter, okay? So yes, the formula is on your formula sheet. Bailey, it's okay. Let's look at the example, okay? Let's look at the example. All right. So let me just give you all the definition first. After you see the example, it will be more clear. Okay. So we all know the confidence interval is a range. It's basically a range. Look at this over here. It's a range. Like it have to be covered. The point estimator have to be inside. So it is a range, and the lowest value from the point estimator, we call it a margin of error. So on the right, they have another margin of error. So you have your point estimator here and two margin of error, and this is your C% confidence interval. That's how you calculate it, that. Okay. And the margin of error of the estimate described by how far at most we accept the estimate to vary from the true population value. That is, in a C% confidence interval, the distance between the point estimator and the true parameter value will be less than the margin of error C% of all samples. Okay, so this is just a definition. And again, like you do not need to really understand what they are saying. And when we see an example, I will bring the definition back and tell you what exactly they're saying. Okay, so let's look at this example. So just read the question very quick. We're going to do it together. Okay. All right. So on your paper, if you have a paper ready, I will challenge you the following thing. What is your parameter? Okay. What is your sample? What is your statistic? What is your confidence interval? What is your level? Okay, I will okay, everybody, we're on example 2. I will take the screen off so I can show you my board. Okay. Where is that? All right. Okay, let me clear the board and we will go from there. I hope you have your PowerPoint pull up on your screen, okay? Okay, the dog is gone. The dog has disappeared. Okay, Andrew, maybe. All right, in this example, what is your parameter? What is your parameter? It's a proportion, a mean, a standard deviation. Okay, we're not sharing Pringles. Okay, no. All right. What is your parameter? 32. Where do you get 32 from? It's a proportion. Thank you. So your parameter is a proportion. The proportion of people who voted who will vote for candidate A, right? Okay. What's your statistic? Statistic is in what is statistic? So it's for the people answer the question. All right, Andrew, just know the parameter is for all the people, for all the American voters. Okay, so for all registered voters. Okay, so your parameter is the proportions of all registered voters who will vote for A. Okay, your statistic is proportion of sample proportion of people answer the question that they will vote for A. Okay, does that make sense? All right. So what is closer and bigger? Yes, absolutely. Is that better? Okay. Hold on 1 second. So now we need to find the confidence interval. What is confidence interval? No, parameter and statistic does not always to be a number. No. So the sample is the people choose to answer the question. Yes. The confidence interval is the range. It's from 0.48 to 0.54. This is confidence interval. Okay. Okay, this is confidence interval. And what is this 95%? What that called? 95% is called what? It's called a confidence level. Okay, so confidence interval is that range. Thank you. Confidence level. Oh, right. Is that better? Okay, I'll get away from there. Okay, so they ask you to interpret the confidence interval. So if you are on your PowerPoint, please go to the confidence level that side. On the bottom, I have how to interpret the confidence interval. Okay, so it's slide number 7. Okay, so to interpret confidence interval, you're gonna say we are how many percent we let me type it for you, okay? Okay, Aiden. All right, so you're gonna see we are 95% confident that the interval from 0.48 to 0.54 captures the parameter. What is the parameter? It's capture the proportions, two proportions. I'm typing it. Of all registered voters who vote for candidate. Okay. All right. So everybody, please look at the comments. I already comment on there. So they said we are 95% confident that the interval from 0.48 to 0.54 captures the true proportion proportion, I don't know where the OS come from, of all registered voters who vote for candidate A. Is that okay? Yes, we need to actually calculate the intervals after we learn the formula, but not right now. Okay, right now we just need to understand what the interval is saying. It's saying the range that capture most of the data. How many percent of the, what the chance of it is 95%. Okay, all right, let's keep going. Okay, we need to see question 2. All right, question 2 is saying, what is the point estimate that will be used to create the interval? What is the margin of error? So over here is our confidence interval, 0.48 to 0.54. Okay, if we want to find the point estimate, if you want to look at the picture on slide number 8, we will see the point estimators will be exactly in the middle of the two endpoints. Okay, so over here will be your point estimator. We're gonna find the average of these two numbers. Okay, so what is the point estimator? Anybody have an answer? Find the average of the both 2 points. Okay. All right, find the middle, which is 0.51. Thank you. So 0.51, yes, 0.51, you just find the average, which you're gonna do 0.48 plus 0.54 divided by 2 is equals to 0.51. This is your point estimator. Okay, point estimator 0.51. And what is the margin of error? So margin of error is over here. What is the margin of error? Plus or minus 0.03. So 0.03 is the margin of error. Good job. Does that make sense to everybody? Ew. Okay, there's too many chairs over here. Okay, all right, so awesome. So they said based on this, let's look at the last one. Okay, based on this poll, a political reporter claimed that the majority of registered voters favor candidate A. Use the confidence interval to evaluate this claim. So what do you think? Can you say that most of the people will vote for A? Okay, Balto is already here, Andrew. You can see him walk around. No, you don't need to say plus and minus. Margin of error is just a number. Okay. All right, I'm fixing that camera right now. Okay. You do C, and then we will talk about it after my camera come back on. Am I back? Lene, really? All right, here we go. So what do you think? I'm back. Hi, I'm back. So they said majority of voters vote for candidate A. But according our confidence interval from 48 to 54, what can you tell me? So that means it can be 40, like majority of the uh, so the voters can be like the situation can be 48% vote for A or like 54% vote for A. So you don't really know like if it's more than 50% of them vote for A or not. So you do not have enough evidence from the confidence interval to say that it's true. Does that make sense? Okay, everybody say no, you are right. Okay, so here is how you explain that. So because they are possible, which is the next slide, because they are possible values of p less or equal to 0.5 in the confidence interval, the confidence interval does not give a convincing evidence that majority of the registered voters favor candidate A. Okay, does that make sense? All right, I'm gonna no, it's a no because in the confidence interval, they can be less than 50% or more than 50%. Okay, all right, let's try this one. If I change the confidence interval to 0.60 to 0.71, so use this confidence interval 0.60 to 0.71. So do you have enough evidence to saying more than 50% majority of them vote for candidate A? We're using this. 0.40, 0.71. All right, I can type it. Okay, let me create a Google Sheet. Yes. Okay, yes, yes, yes. Thank you. All right. So if you didn't hear my question earlier, let me put my face away. My question is if the confidence interval was 0.6 to 0.71, can you say majority of the people vote for? Okay, so the answer is yes, because inside the interval, like most of the data in the interval is over 50%. Here is from 60 to 71. So you can say, okay, most of the people vote for it. Okay, all right. Okay, I lost my slide. All right, so today we're just gonna end here, okay, because it's been 45 minutes ish. And tomorrow we're gonna keep going. And a lot of you guys, if you join like the midway, and if you are confused, just look at my PowerPoint. All my explanation, all the keys are there. Today we did from number 2 to number 10. Okay, tomorrow we're gonna finish them. Okay, all right. Let me see some question. So I have a question. What if the lower interval is 50? Well, Mike, if it's from 50 to 56, everything is over 50, so that's fine. Okay, that's fine. You will say yes. Majority of them uh, vote for candidate A. Thank you, Fred. I will assign you. I don't know. I guess I'm not checking homework. I would just like maybe assign you Khan Academy once a while, maybe once a week, two of them at a time, and you just do that. Then I just according to if I see you in the video and if you did the Khan Academy and give you a grade eventually, I guess. Balto time, Andrew, I got it. I need to read the comment, okay? Show the board again. Yes, I can show the board again. 1 second. Display. Okay, can you see the board now? What's wrong with Khan Academy? I love Khan Academy. Okay, here's the board. If you have any question, let me know. Okay, let me like ask you a question. So, do you think you will have time to see me every day? Because this is not goes as fast as I thought. So, like, can we meet every day, or you prefer just meet 3 times a week, maybe? All right. Okay, if you hear me, answer my question. Okay, meet every day. We just meet 40 minutes. Is that okay? Yes or no? Okay. All right, so how about let's just do 3 times a week, and next time I will see you will be on Thursday. If you tomorrow I will be online, and well, we didn't actually learn so much, so I don't have too much to like show you. All right, so like okay, next time I will see you will be on Thursday. Is that okay? Okay, can we do all right, we're gonna skip tomorrow. Can we meet Thursday and Friday? Is that okay? Okay, just type yes if you think it's okay. Thursday and Friday. Yes, it still will be at 11. If you cannot join, it's okay. You just like watch the video early later. Okay, so we will meet again Thursday and Friday at 11, and then next week is will be spring break. You can like do whatever you want in spring break. I'm not taking that away from you. And then after we come back, we are doing Monday, Tuesday, and Thursday, and see if we need Friday. If we need Friday, we meet on Friday. If we don't, that's it. Okay. All right, so bottle time. If you, I have nothing else to say. So if you want to leave, please go ahead, leave. Rest of time is just a dog. Okay. All right, come on, okay. Bottle cup. All right, here we go. Bottle, come here. Come here. Come here. Are you? Okay, here's the dog. Hi, Bottle. You are famous. Look at the camera. Bottle is not very happy because I'm not taking him to park because I can. Yes, he can do tricks. He can. He's not very happy right now, so I don't have treat neither, so I don't know how good he will do. All right, baby. Bottle, come on. Sit. Okay, you cannot see. Lie down. Lie down. Sit. Talk. Bottle. All right, guys. Do you want me talk to him? He can talk. All right. Yeah, he can do flip. He can do roll over and stuff, but you cannot see because I don't know how to adjust the camera. Do you wanna hear Husky talk? All right, let's see. 包头 sit， 包头哎，包头你干什么？你怎么嚷妈妈？包头，包头，包头。 Balto. Balto, go say. You can say bye to everybody. Say bye. All right, guys. Okay. Oh my God, we're just gonna. Okay. One of these days, we probably will just cancel the stats class and let him talk. Balto, say bye. Balto, say bye. Say bye. You can say bye? You don't know? Okay, Tatiana, we're still working on it. He does not know how to do that. Bring him to your work. Where you work at, Andrew? All right, guys. If you wanna leave, you can leave. I'm not. It's like we're done for today's class. Rest of time is just Balto. Okay. Andrew, where you work at? You work with animal? If you work with animal, I guess I can. But restaurant, I don't think so. Really, Tatiana? You give dogs free chicken? We want a free chicken. Can I really bring him? I don't know. Like, okay, Tatiana, you cannot like feed your stuff. Oh my God. Okay, guys, you hear him talk. We gonna go to grandma's house and send her some toilet paper now. So, really? All right. So we're gonna go send toilet paper, and I hope you guys stay at home and be safe. Okay, and protect yourself. Okay, and I will see you on Thursday. And if you need me for anything, just let me know. And I just currently have a Google Hangout account and stuff. I don't know. I still don't know how it works, but like we can probably like solve your problem using the software or something. Okay? All right, I'm leaving. Bye. Have a good day and I'll see you on Thursday. Bye-bye. Bye, guys.